In this video, I'm going to create the service discovery. But before that, I will talk a little bit about the service discovery. If you're into microservices architecture, you may have heard of service discovery. In microservices, each program or server is running on a separate server. Each server has different IP address, and it is not suitable to hard code the IP address in your code because they may change. Especially if you're launching the servers using any automated software. In this case, it's not possible to know the IP address. To solve this problem, we can use service discovery, which keep track of each server IP address. In this diagram here, the big circle is the microservices we're having here, and service A, B, C already in the microservices and using its own IP address. And let's say in order to complete the task, service A need to contact service B contact service C, and service C need to contact service X to complete it. But service X is not in the system yet, and service X want to join. When service X joining to the microservices, the other services don't know about the IP address of this service. What need to be done is service X need to register itself with the service discovery, say what IP address is holding and what service name it is, and then this record into the service discovery cache. Service A can just request the name of service, which is service X, to the service discovery, and then get back the IP import of this service, then can connect directly to the service X to complete the task. Each of these services, when they join the microservices and register with the service discovery, need to check whether it's still up and running or crash. For that, we need to get back to each service and see whether it is accessible. For this, we need to contact each of these services once a while to know the service is up and running or not. If the service is accessible, record will remain in the cache, otherwise we're going to be deleted. The other services do not contact the wrong IP, which service is already crashed. Here, let's say the user request the order, want to purchase a product, and the order first going to hit the order service. The order service need to check two things. First, maybe more than two things, but for now, for simplicity, I just keep it simple for two things. So it's going to check this user have enough credit inside the account to purchase or not. It's going to contact the user service. So this is the first checking. The second checking is that we're going to check the product is available. So for example, if there is one remaining of the product and two users at the same time order the same product, first user will going to get the product, then the quantity will be 0 out of stock, so the second user is not be able to purchase the product. After these two checks validate, order service is going to update the product quantity and then update the user. So updating the user is that so the product need to add to purchase product of the user. The first thing I created here is the RPC server and the TCP listener to receive the request from other services about getting the IP address of another service. Next I need to do is to create the methods for this RPC. each service is going to register with the service discovery. It need to be validated. So sometimes they forget to pass some IP name or endpoint for all these things. So before getting to the problem later on, we need to validate all those data. So here we're going to validate three things. One is the name of the service, which other services need to look for it based on this name. It's just a simple string name. And then the second thing is going to be the IP and the port of the service. And the third or the last is the health check endpoint. So here I use one of the library or the auxiliary library that I created earlier for myself. So it just basically generates a random string um, and based on the number that we give here, based on the quantity that we give here. So 5 means 5-digit random string. And then we need to have a cache package here to add data. So the cache package actually is the package that is going to handle the Redis. So here I create the very first code for connecting to the Redis. In here also I'm going to use auxiliary library that I created myself for reading the environment variables and then getting the Redis client ready to connect. And lastly, we're going to check before contacting it. So here we need to run the cron job to check once a while the health check. So I want to have the function for this to create a new cron job based on the data that I provide, which is the endpoint, and the health endpoint is there, health check endpoint is there. And then I want to define how long will be the gap. So for example, here I mentioned like 5 seconds, it can be 1 second or whatever you decide. But I think 5 seconds for this video should be okay. Usually it's going to be based on how much traffic you will have on that server. So if that service is going to be a high traffic, so maybe you need to check it like millisecond or something like that, or 1 second. But for now, I think 5 should be fine. Okay, now I need to create the Redis on the Docker. Okay, so basically I create a very simple Redis Docker file, and acquiring the password and passing it with the environment variable, and let's see if it runs. Okay, apparently it's working. Let me check. Okay, the Redis is up and running. Okay, good. So right now we don't have anything because there is nothing registered in the cache yet. But this is showing us that the Redis is up and working, is working on the Docker properly. So now I need to create a Docker for the service discovery itself. Okay, now the discovery and the Redis Docker are running. Good. So now next is to create the order service. Okay, now first thing we need to do in the order service is to register with the service discovery. Okay, so basically here I'm going to create some credentials for this service, and then call the server discovery, and then it's going to request for registration, and then pass the details of the service, and then we return the generated UID from the service discovery. And just for the information, we're going to display the UID of the registered service. We have a problem here because I haven't passed the IP and port, so it's going to be empty. So to do so, on the Linux, which is my main operating system, I know that we can get the IP address of the server or the running computer is this. I haven't tried this on the Mac OS, but this is how it works. And then why I'm doing this, because if we put 127001, it's not going to work because we're running it on the Docker container, and the Docker container is not using that IP. Okay, now we have another error, and the problem is that AWS is not a command. AWK is the correct command. So yes, now it's correct and I'm getting it. So when we register it, we're going to have that order here. As you can see, we have the service name and the generated UID for this service. And if we check again, it's not going to be there, because after 5 seconds, it's going to call this service to see whether it is alive, working or not. And obviously not, because it's just register and just exit the program. Okay, now I used the latest Go version. So the new Go version have a very good routing system. Previously, when I was starting another series in 2023, the Gorilla Marks was discontinued and archived actually, and then I forced to create my own routing system. But then recently, just a few weeks ago, the Go version 1.22 came out, and then they already implemented this routing, and it's very convenient actually. So as you can see, I don't use any third party for the routing and the HTTP server here. So once we have this, we're going to try to check again. It's going to stay alive and stay connected to the service discovery. As you can see, still we have the order service with the UID here. We can check again and it's still there. So now, since we have all this working together, we need to create another service, which is the product service. So for the simplicity in the product service, I'm not going to create any database, so I'm going to just hard code the products inside the code. Okay, now what I need to do is to create a HTTP server for the endpoints of getting the product detail based on the ID, as well as updating the product. And also we need the last one, which is the health checking for the service discovery. So in this handler, I need to get the product based on the provided ID on the URL parameter. And then after that, we marshal it to JSON and then respond it back. Okay, now I need to update it. After the purchase already completed, I need to deduct the quantity from the product. Alright, so in this, I just collect the same ID that is provided on the URL parameter. Find it from the map that we have here. Deduct the quantity and then place it back, so the next time the quantity will reduce. So this one is just like mimicking how you interact with the database. So you read from the database, update the database, and that's all. So now I need to check is it working or not. I did not get this as registered, so that means something is not working here properly. And the problem is that because I'm opening the wrong port. And see whether we are registered properly. Yes, so the product is healthy. Now we can check that the product is here. So the other thing we can do is to run the order. So now we can see we have both of the services here, order and product, and still up and running. And if now we try to get this, as you can see, we get the product back. We change the ID. We're going to get the product B as well. Okay, so that's showing that it's working. And then we have the update and update the product after purchase. So this is basically just deduct one of the quantity. So every time you send this, is going to reduce the amount, and we get 200, which is we have quantity. If we change it to this, which we had 2 and 2 times, and the third time say bad request, means is out of the quantity, is out of stock. Okay, now I need to create another method for the service discovery to return the IP address of the requested service. Okay, both services are up and running. So as you can see, we received the IP address of the product, which is only on the local host, is the 7070, and the order which we receive here is 6060. So the 7070 is the IP and the port of the product service on my local machine. So now we have the address of the product service. We can call the product service on the endpoints for getting the quantity of the product and then update it. And you can see after that the quantity change. So what happened here is that the user sent the order for to the purchase endpoint to the order service, and the order service will check with the product. So if the quantity is still available, it's going to deduct 1. So here is the endpoint for the purchase on the order, which is the port 6060 and the product is XXX. So the product ID is this. And then when we send this, it's going to check and then update it. And here in the product, if we get that, the quantity was 9, it should be 8 now, it's 8. So if we change this to product YYY, that also need to be updated. Yes. So after that is going to be 0, means out of stock. So if one more time after that we will try, we get insufficient quantity, which is not found, the product is not found. So I created the service discovery, 2 services, which is the order service and the product service. They communicate each other in order to complete the task. And each service is registered their own IP and the port to the service discovery, provide the health check endpoint to keep track of the health of the server, and providing the IP address of other services. And that was all for this video, and thanks for watching.